That is a great question for an amateur radio operator. The length of a half-wave dipole antenna, which is what an inverted V is based on, is primarily determined by the frequency and the velocity factor of the wire. For your specific antenna design, frequency 7135 kHz or 7.135 MHz. Wire 2.5 square millimeter insulated copper wire, likely PVC or similar insulation. The insulation on the copper wire slows down the radio wave, which is accounted for by the velocity factor. For bare copper wire, the velocity factor is very close to 1 or about 0.95 to 0.98. For PVC insulated hookup or house wire, the velocity factor is typically lower, often falling in the range of 0.93 to 0.97. I will use a standard conservative value of 0.95 for insulated wire for this calculation. You may need to fine-tune this by trimming the antenna once it is installed. Formula for the total physical length of a half-wave dipole antenna in feet is 468 divided by frequency in megahertz into velocity factor, and in meters it is 142.5 divided by frequency in megahertz multiplied by velocity factor. So for 7135 kHz with a velocity factor of 0.95, the length in meters will be 142.5 divided by 7.135 into 95. That will be 19.97 into 0.95. So it will come to finally 18.97 meters. An inverted V antenna is a half-wave dipole antenna bent at the center. The total length is the same as a horizontal dipole, but it's typically cut into two equal halves. Total antenna length 18.97 meters. Length of each leg 18.97 by 2, approximately 9.485 meters. The calculated length is a great starting point, but the final most accurate length is determined by your specific environment, height above ground, surrounding objects, type of insulation, etc. Cut the wire slightly longer than the calculated length. Example, 19.5 meters total or 9.75 meters per leg. Install the inverted V. Use an antenna analyzer or SWR meter at the feed point to check the standing wave ratio on 7135 kHz. Gradually trim equal lengths of each end of the antenna legs until the lowest SWR is achieved near your desired frequency 7135 kHz. I made this antenna as described and mounted it in inverted V fashion with apex at about 10 meters from ground and ends about 3 meters from the ground. Check the SWR in my FT710 radio and got SWR of near 1:1 on 7135 kHz. SWR was near 1:1 down up to 7100 kHz. SWR on 7190 kHz was also near 1:1. At lower end of the 40 meter band, it was around 2:1. That is tunable with auto tuner in the radio, so I did not go for any trimming. I used 15 meter long RG58 coax with pre-crimped PL259 at lower end. Upper end, I removed the insulation and connected directly to the antenna wire, as I do not have a spare balun at the moment, and insulated with usual adhesive tape followed by silicone tape for waterproofing. Silicone tape was stretched as much as possible and wound tightly at the joint so that I hope it will be waterproof. You may remember that my RG213 had got spoiled because of rainwater seepage.